Hello students, this is Deepak Pandey and we are on the solution of various questions asked in examination in electrical machine 1. Today we will discuss about the energy balance equation for generator and motor. So moving on the question which is based on the energy balance equation of generator and motor, we will first discuss that what is the basic principle of generator and motor. So these are the devices based on the principle of electromechanical energy conversion. While the devices, the input energy is equal to the sum of three components. First one is the energy dissipated. Energy dissipated, that section leads the losses. Next one is the energy stored in the magnetic system, and the last one is useful output. In the case of motor, this useful output is useful electrical energy, while in the case of generator, this useful output is the mechanical energy. So the energy balance equation provides the relation between the input and corresponding output. The energy balance equation may be written as total energy equals to input equals to the energy output, the increase in energy stored in magnetic field, and next one is the energy dissipated. Clear? So the input energy basically divided into three categories. If we have considered a prototype of motor like this, motor or generator, or we can say an electromechanical energy conversion device given by this circuit, and we have input of energy like there, then the rotation start. Okay, next thing is the losses occurs and there is energy output. In case of motor, this energy input is electrical energy and this energy output is mechanical output, and in the case of generator, this energy input is mechanical energy while the energy output is electrical energy. Losses are basically electrical and the mechanical losses. So the total energy stored in electromechanical energy conversion is what? The energy stored in mechanical system plus the energy stored in the magnetic system, and the total energy dissipated, that means losses, contains first one is the ohmic losses, energy dissipated in electric circuit due to the presence of current, due to the presence of resistance, and whenever current passes through it, there is an effect of I square R that is responsible for ohmic losses. Next one is the hysteresis and the eddy current losses. We have studied about both the losses, hysteresis and eddy current losses, and the last one is the mechanical system losses. Mechanical system losses are basically friction and the windage losses which occurs due to the presence of mechanical components. For motor, so energy balance equation for motor is electrical energy input is divided into three parts. First one is the energy to electrical losses. Electrical losses means these are the losses due to the presence of resistance as well as the core. Next one is energy to the field in electric system, and last one is the mechanical energy output. So this is the basic energy balance equation in the case of motor, or by the mean of block diagram it be represent like this. So there are electrical source provides the energy input, electrical energy input, and so gross electrical input is V into I, where V is the voltage applied by the source. Then the losses occurs, electric losses occurs in the windings. I square R loss is electrical loss. Then we have net electrical input, where small e represent the EMF, and we can say that this EMF is nothing but the back EMF condition. Okay, then this is fed to the coupling field, and next one is gross mechanical output is there. where TA is the air gap torque, and after that mechanical losses occurs and we get omega into tau sh, where sh stands for the shaft torque. When we move up the generator, then the energy balance equation of generator may be look like that: total energy input equals to total energy dissipated, losses occurs there, energy to the field storage in the electric field, and after that the electrical energy output. When we talk about the simple block diagram, so the block diagram of this particular process may be looking like this: mechanical energy input, then after the coupling of field coupling, and after that the electrical output. The various steps occurs over here is the gross mechanical input omega into tau sh, again tau sh, whatever the torque is fed to the shaft multiplied by omega is the gross mechanical input. Then the mechanical losses occurs. These mechanical losses are windage losses, whereas the friction losses. After that we get the net mechanical input as omega into tau, which is fed to the coupling field, and the gross mechanical output E into I is looking over there, and this E into I or gross mechanical output is just equivalent to the product of EMF produced at the armature side multiplied by the current. Then electrical losses occurs, and after that we get electrical output as V into I, where V is the terminal voltage. This video lecture series will help you to perform well in university examination as well as to improve your concept. So please subscribe the channel और प्रेस बेल बटन, जिससे आपको टाइमली आने वाले वीडियोस की इंफॉर्मेशन मिलती रहे. थैंक यू सो मच एंड ऑल द वेरी बेस्ट.